this session number 303 morning, and today I will try to resolve this problem. This is the daily challenge. Looks as an easy problem. And okay, delete nodes from a linked list present in array. You are given an is the problem 3217, and is you are given an array of the integer nums and a head of the linked list. Return a head of the modified linked list after removing all the nodes from the linked list that have a value that exists in nums. Okay, for example, we have the nums 1 to 3, and we have the linked list. The 1 that should be removed, the 2 is the same, the 3 the same, and the final is only 4 and 5. Okay, it's possible to have, okay, this is a good hint. It's possible to have duplicate numbers, but it doesn't matter how many numbers appear here in nums. If, for example, if you only have one, or only have a single one, you need to remove all the ones that appear. Yeah. Yeah, basically it's this. Okay. Nums length, the minimum size is 1. The maximum is 10. Nums, the value of the every nums is at least 1. The same. All the elements nums are unique. Okay. The numbers of nodes in the given list is the range between 1. Okay, the list can't be a null, and the node value is between 1. Okay, the input is generates such that there is at least one node in the linked list that have value not present in nums. Okay, looks easy this problem, but okay, let me open this. I think that okay, and next to is this image. Okay, now I will use this example. Let me share the problem here in the description. Okay, well, for this problem, the first point is that these numbers are unique numbers, and it's an array. Yeah, in this case, I would like to use a hash set. Yeah, because it's cheaper, the query over the set compared with the array, because in this case it's not sorted. Well, the first point is add in a set. Yeah, and okay, we have these values. Now the next step is have the reference. In this case is a head. This is important. The first element could be have a number that appear here. Means that it's possible the first node will be removed. Yeah, and for this we can use a dummy pointer or dummy node. That, for example, here less 1. The next reference is basically, okay, we need to start here this number appear in this list, yeah, okay, move with the next. This number appear here, yeah, move to the next. This number appear here, yeah, move to the next. This number appear here, no, okay. In this case, the temp node dot next is equal to the current node, yeah. Now the next that is this number appear here, no. In this case, the next is basically the number 5. Okay, now let me check what happened when we have, for example, here another 3 and 7. Yeah, do you imagine that we have here the set, yeah, and we start here, we have our temp node, and it's okay. The first, we start here, the first is in this set, yes, or okay, only move is ignore. This is in this set, yeah. This is in this set, yeah. Move with the next. This is in this set, no. Okay, temp dot next it's equal 4, and temp it's equal temp dot next, yeah, for move here. Okay, now the next, this is in this set, no. Okay, we can create this, and it's basically repeat this operation, and now we are here. Now the next that is 3 appear here, yeah, okay, it's ignore. And this 7 appear here, no, okay, this is next. And basically we should apply this operation. Well, before is this, and next to, and after is this, okay. And the final is only return temp. No, I need a reference of this for return temp dot next. In the case that is all the values appear, for example, do you mean here nums have 1, 2, 3, 4, 5, and 7. If all the elements appear here, it doesn't matter because the temp dot next should be null, yeah. But I remember that here appear the input is generated such that they at least one node. Okay, yeah. But well, this is the idea behind this. Okay, now to resolve, basically, I always forget. I forget to execute this. Okay, now now here we need to create the list node result. Now the first is temp, it's equal new command list node with the value less 1, and next to is list node. Today I don't have too much ability with my hands. Okay, list node result it's equal temp, yeah, to keep the reference, and next to is basically a while. Oh no, the first is for each, and here I need a hash set with the integer set it's equal new hash set, and next to is a for that integer n nums okay, nums, and here is set dot add and n, and here is okay. Now here is a head, it's different to null. Okay, the first that is if head dot val, no, set that contains this, but negative if doesn't contains, is basically execute this operator. In other case that is contained is only ignore. Yeah. Now here okay, here I can use the temp dot next, it's equal to head. Now, but before okay, temp dot next, making the is this, and we need to save the reference. Here is this node ahead. No, t it's equal head. Yeah, this case is t no. Okay, we have ahead. If the value is not contained, temp.next it's equal ahead. No, it's only that. And here is basically here is head. No. And temp it's equal temp dot next to move to the next, and head here is head dot next, and okay, here and the final is temp dot next it's equal null, and the final is only return result dot next. Okay, let me check. We have the temp, the result, the for. Okay, ahead it's different to null. Okay, we need validate the value. In this case, for example, the first time, or for this case, the first is a number that appear here. Yeah. Okay, only move to the next. Is the same. Move to the next. Move is the same. Move to the next. In this case, the for is not contained. Okay, we can create temp.next is equal the for, and we need to move in this case and ahead. Yeah, I think that. Okay, let me first submit this answer, but I think that is easy. It's an easy problem because it's basically only the linked list. But I think that when you are new in the linked list, maybe it's hard, but or medium, but well. Let me. Oh, I forget to create my solution. Come on. Yesterday I keep with the idea to resolve the problem that yesterday I resolved in another way, only using one loop. But before I will create this. The solution using nodes, dummy nodes, yeah. Yeah, it's easy. Okay, yesterday, what is the problem that yesterday I resolved? Was this right? Okay. What's this? Okay, let me And but before, let me check the other answers. And this is more faster. Mm, okay, let me come back to this. Yesterday I saw that it's possible resolve in another way. I don't check the answer, but it's possible, and with this is enough for me to try. Okay, what is my section of the this node is here. Ah, come on. Okay, I will move here. Okay, let me move this. Okay, we have this. What is the remove the elements? No. Okay. Now, mm, let me check how many. Okay, and I will try to resolve this problem in another way, because yesterday basically the first is okay, create a monotonic stack, and next to do this operation. But uh, yesterday I discovered that it's possible to resolve in the same iteration, and I would like to discover how. Okay, now we have the head here. Move every node. Ah, okay, yeah, sure. And we start here. This is the result, and we start here. And the idea is that have an decrease decrease um, stack. Yeah. In this case, for example, we start with the we start with the 5, next is 2, now the 13 is remove this and keep this, and now it is the 3, and now the situation is that when you have, for example, the 5, okay, and move with the next is the number 2, and in this case, it's okay, yeah, it's okay. Now the next is, we are here, this should be remove this and this. How can I come back to this? One way that I think in this moment is have the reference. For example, this is our list, yeah. In this list, it's ahead. Okay, have another yeah, dummy that should be ahead of the result list. In this case, the first time is null, sorry, the first time is 5 2, yeah, okay. Now the 5 is odd, it's okay. Now move to the next, and the next is the number 2, it's minor, yeah. Don't remove this. Now the next is 13, this should be removed the 2, okay. Yeah, yeah. My idea is this. Let me show you with different colors. Come on, here. Okay, now my idea is that you start here. Yeah, the yellow is basically the normal for each, or the normal transversal, and you start here, and you have, for example, here a dummy that is starting 5 2. Okay, and we have another reference that is result, that is basically the dummy. Yeah, now we start here, and okay, the first time is empty, 5. Now the next is 2. Okay, 2 is in decrease order, yes sir. This is, should be moved to 2. Yeah, sorry, this move to the number 2. Okay, got it. Now the next, and this is keep the same at the beginning. This is the reference of the dummy. Now the next is this is 13. In this case 13 is greater, should be removed the 2. In this case, for example, we start the for each starting here, and basically is when the next, no, even not only the 2, I need only remove all the elements. For example, here, okay, it's 13. Let me delete this. Okay, our current number is this. Got it? We need to remove the elements. In this case, is the 2. The last element that was removed is the 2. Now the next is the 5. This is replaced for 5, and keep it this. Now we need to remove all the elements that have remove this number of the dummy. Basically, removing this is removing all the others elements. Yeah, and we start here. Dummy starting less 1. Okay, the next is less 5. Yeah, please remove it and put the 13. Yeah, in this case, this is remove it, this is remove it, and already have this number. Now the next that is the number 3. The number 3, it's okay. And the next is the 8. The 8 is greater than this. The last number is this. We need to start again to 13. Yeah, for this reason it's important keep the reference to less 1, because all the time we can start again, and in this case, for example, start here, and is okay 13. Now the next is the 3. Okay, this is should be removed and connect with the last. Okay, now okay, in this case, okay, we have a dummy. This node dummy, it's equal new list node with the value less 1. It doesn't matter the value, but here is result. No, this is not result. No, yeah, result it's equal dummy. No, it's equal dummy. Yeah, and next to basically it's a while. And here we need an stack. Here this stack is the integer stack. It's equal new Here is ahead, it's different to null. Yeah, this is for each, in this case list node. N it's equal ahead. Let me change to node. It's equal ahead, okay? And now we need validate here should we have a while for the monotonic stack. Meanwhile, stack is empty, is not empty, and stack.pick is greater, no, it's minor to to node.val. In this case, we need remove stack.pop and this value here. Large element remove it's equal 0. Yeah, this is basically this. No, even less 1. Let me check what is the, yeah, or 0. No, it's okay with 0 because the node files should have the at least 1. This is the minimum value. Yeah, and we can remove here. Now here we need ask we'll remove the elements if last element is greater than 0. Last element is removed. Last element is greater than 0, yes, or in this case I need for each the dummy, yeah, while while dummy dot val, no sorry, next dot val it's different to last element remove dummy it's equal dummy dot next. Yeah, in this way basically we are moving until the dummy is okay, in this case here find this element that should be removed. In this case is dummy.next it's equal to n to node and dummy it's equal to result, yeah, to come back to the first element. And what else? And I think it's return result dot next. Yeah, sure. Head should be moved. Head dot next. Result is equal dummy. I'm sure. Okay, we start ahead is different to null. Now it's equal ahead while stack in this case here when wasn't remove any element, basically is dummy.next. It's equal node, and here is dummy, it's equal dummy.next. No. It is wrong because the problem is here. This is okay because basically the number is it's minor, only add. Dummy.next it's equal node, dummy it's equal dummy.next. Now, got it. Here is that this should be execute all the time. Okay, and here for use this basically is a temp. It is node x it's equal dummy, and here is x.net, no, result.next. Here is this is this is wrong. Dummy it's equal dummy.next. I am not removing any element. Oh, sure. Here is x. Yeah, what happened when find the element and we need remove until find them. In this case, for example, if we are trying to delete this number, for example, or this. Okay, we start in 13. The next that is the number, okay, keeping the 13, and is the current node dot next is equal node. Here is, in the case that doesn't exist, dummy. Here is dummy. The next is equal node. What? It's a typo. Dummy dot next. What? Okay, the last element was remove. Okay, please remove. For example, we have this, now we have this element, this should be removed, this. Okay, start here. I think that is for the reference, but mm, mm, mm. Mm, could be possible save the in the stack these objects. Okay, let me check. Okay, because in this case, when the element, okay, we have the element is okay. Happen this situation. In this case, for example, no, this is not execute and should means that dummy dot next is equal a node in dummy it's equal dummy dot next and ahead it's equal ahead dot next. Okay, basically it's moved to this. Now is the number two. The while is not execute. The while that where stack is empty, blah blah blah, is not execute. Last element is not execute too because never remove any element. And is dummy dot next it's equal to, okay, currently we have the reference, and dummy it's equal dummy dot next. This is moved to this. Okay, now in the next is 13. 13 is greater than 2. Yeah, it's greater than 5. Yeah, the last element that was being removed is the number 5. Okay, we have the result dot next as a copy. Result dot next means that the 5 yeah, for this reason never, yeah, it's for this. What? In any movie remove, okay, basically here start with the less one or is 0, yeah, less one, and we should ask less one dot next it's different to the number 5. In this case no. Okay, keep in this moment in x dot next, yeah, in this case is less 1. The next pointer is 13. Yeah, in dummy yeah, I need here, I need say set say that, yeah, because here I am modifying the result, but I need not modify the dummy too. In this case is dummy it's equal x. Come on. Last element is greater than 0. Okay, we need move. In this case, okay, I will copy this solution because I am trying only add with all thing too much. And come on here, and white, and let me remove this, 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 this. Okay, now here Okay, now we start. Okay, we have dummy it's equal less one, yeah. Result it's equal this, means that less one, yeah. And the stack, okay, and we start here and we say node it's equal 5, okay. Last element is 0, okay. In this case, for example, sure, in which moment I add the element to the stack. Oh my god. Stack dot push node dot n val. Yeah, maybe it's for this. Oh, it's too slow. Even my previous answer was oh my god, it's too slow. Okay, no, I will check the solution using the stack recursion. Not all of these are linear. No, I remember that I saw a solution maybe here. Yeah, this solution. Okay, I will. Okay, at least I create another kind of solution. Slow, but another. Here. Okay, what happened here? The first, I create this is, yeah, this is Kotlin. But well, I write the queue, list node, current ahead, meanwhile, the queue is empty, and core.val, that is the current value, is greater than the last. Remove. If the queue is empty, if the queue is empty, ahead it's equal core. In other case, the queue.bclass .next it's equal oh wow. Yeah, basically here yeah, use the queue. Yeah, I think that it's right. Yeah, even here, yeah, makes sense, because basically you can save the stacks here. For example, here replace this for and this node. Let me remove these elements. Yeah, and have here well, ahead it's equal. Okay, let me create list node node it's equal ahead, only for no, don't forget ahead it's equal ahead dot next. Okay, now here is basically while stack is empty but negative, and stack.pick .val it's minor to node.val is basically stack.pop. Yeah, and next to we need say stack.pick .next it's equal node, yeah, but here I need to validate if stack, because could be null, no? If the stack is empty, oh, but it's not negative here. It's basically no, sir. Is here is only dot push node. In other case, when the stack is not empty, stack dot pick. Come on. Dot next, it's equal node, and the final is basically only remove all the elements, and the first element should be the answer. Here is while stack dot is empty. Here is list node result. When I have result here, result it's equal stack dot pop. Yeah, and here only return result, and result yeah, this not necessary, it's not necessary here. Oh, I need the null. One what? Why? Why? With one one. Why? I am okay. Apply this. Oh, but here when no, it's okay. Stat.pick.next is equal node. Ah. Okay, let me check another test. It's the same, right? Okay. 9-1. The first and the last. Only add two elements. Why? This stack only have one. Yeah. All the time I need to add the value. Here, for example, is stack.pick like this, and add the value. I still getting a very bad performance. I am in the last. What? Ah, well. Yeah. At least I create three different solutions. It's not the best performance, but I learn. Okay.